All right, so we have reviewed Unit 1 Astronomy in our first video, and now we are moving on to Unit 2, which is Plate Tectonics. Again, we're going to review some of these questions from a re-looping quiz, which just means a review quiz. These will not be all of the questions that are on your practice/actual midterm, but there are some of them that you will see. So it is in your best interest to make sure that you complete this and have a good foundation for taking your midterm next week. So let's go ahead and jump into it. So this first question says, which of the following best explains why Earth is tectonically active? So to answer this question, we have to make sure we know the composition of the Earth and kind of what's going on underneath it. So if we remember, there are three different layers. The top layer is the crust, the second layer is the mantle, and the third layer is the core. Now, it's a little bit more complicated than that, but on a basic level, there are those three levels. If we were to walk outside right now, we would be on top of the crust. It's solid, it's thin, it's typically brittle. And then underneath that, we've got a solid upper portion of our mantle, and then we have a really hot liquid portion of our mantle. So our mantle is not all solid. It's got a solid upper portion, but the middle portion is so hot that that rock actually melts and becomes molten. So that's where we get magma from. That's where magma comes from. So because of this, we have those convection currents, okay? Convection currents in our mantle that will heat and rise, and then as they get closer towards the crust, they will cool down, become more dense, and they will sink. So it's like that conveyor belt motion, that pattern in the mantle that will push our plates and will move our tectonics forward. So knowing that, go ahead. Again, I apologize for the bell. So go ahead and pause and try to choose the answer choice that goes along with explaining why the Earth is tectonically active. All right, so we should have chosen B. So Earth's solid surface layer sits on a layer of semi-molten rock that slowly flows. So that solid surface layer is the crust of the Earth, okay? And it sits on top of the molten portion of the mantle. So the upper solid portion of the mantle and the crust sits on top of that molten portion. That just means the melted portion. And as those convection currents in the mantle are flowing, it's pushing our plates around and it's causing that tectonic movement, okay? Question 2 says, a geologic cross-section of the Himalayan mountain range is shown below. This mountain range is the result of which type of boundary? Well, there are three different types that we have to know about. Divergent is when two plates move away from each other. Transform occurs when two plates slide past each other. And then convergent occurs when two plates move towards each other. Okay, so those two plates are moving towards each other. Now here we have these mountain chains formed, and these are the Himalayan mountains, and these are non-volcanic mountains. Okay, so there are no volcanoes happening here because there's no subduction zone. Okay, we don't see one plate being subducted beneath another and pushing up the magma. So we're not going to see any volcanoes here. So knowing that, we can first of all eliminate the first and last answer because we know we're not seeing a divergent boundary because we get mountains when two plates push together and they push the crust up and form those mountains. Okay. But what we need to know is this occurring between two continental plates, or is this between two an oceanic and a continental? Well, take a look at this diagram. Take a look at this crust right here, what it's labeled as. And then take a look at this crust here, what it's labeled as. And then pause and make your selection for this question. So we should have chosen convergent boundary between two continental plates. okay, because this is a continental crust and this is a continental crust. And when two continental plates come together, we get non-volcanic mountain ranges. All right, so I don't have time to review all of that, but back in Unit 2, you guys have that graphic organizer of the different plate boundaries that we did together. That's a really good one to review before your midterm. Okay, so question 3 says the diagram shows the motion of tectonic plates. Which term provides the most accurate classification of the geologic structures shown? So this is going to be a type of fault, all right? This is a fault. We can see the crack in the earth, right? So this is typically along where we're going to see earthquakes start. And since we know it's a fault, we can go ahead and eliminate these two answer choices. So we know it's not a fold. We know it's a fault. It's a fault because it's broken. We're going to see the movement of these two plates past each other, and we're going to see earthquakes. Okay. Now we have to determine whether it is a reverse fault or if it's a normal fault. Okay. So a reverse fault typically will have the hanging wall being thrust up against the footwall, okay? And you can always tell where the footwall is because it makes an angle greater than 90 degrees. So if we take a look here, if we take a look at our one plate here and take a look at this angle, now a perpendicular angle, 90 degrees, would just be like a corner. So this would be a 90-degree angle. This angle is wider than 90 degrees. Okay, so this is our footwall. All right, so our footwall is here. In a reversed fault, our hanging wall here would be above our footwall. So it would be pushing up above our footwall. In a normal fault, our hanging wall here would be pushing down and be below our footwall. So knowing that, go ahead and pause and make your selection for this question. So here we should have chosen a reverse fault, okay? Because again, in a reverse fault, we have our hanging wall that is thrust up above our footwall, okay? So since our hanging wall is up here, we know it's a reverse. And again, you can always identify the footwall because it will have an angle that is greater than 90 degrees, which we see right here. All right, question 4 says, which of the following sequences correctly lists the different arrivals from first to last? So these are our seismic waves that are coming during a hurricane. Not a hurricane, I'm sorry, during an earthquake. We haven't gotten to hurricanes yet. These are the different seismic waves that occur during an earthquake, and they move at different speeds. So they come and they're recorded on a seismograph at different times based on how quickly they're moving. So there are primary, secondary, and surface waves. Remember, those surface waves are the ones that are going to be the most destructive because they occur when the primary and secondary waves come together. So primary means first, secondary means second, and then those L waves or surface waves, those come at the very end when the destruction really happens. So knowing that primary means first and secondary means second, go ahead and pause and make your selection for this question. Okay, so we should have chosen B because our primary waves will come first. Remember, those are those waves that aren't quite as destructive. They move really quickly. S are our secondary waves that they come second. And then our surface waves are those destructive ones that come very last. All right, and then last but not least, this question for today says active volcanoes are most abundant along the... Now, think about where do we see volcanoes? Okay, we see volcanoes and volcanic island arcs where we have subduction zones. So subduction zones will happen where we've got convergent boundaries, so either with a oceanic crust converging with a continental crust, or with an oceanic crust converging with another oceanic crust. So we have a subduction zone where the magma is pushed from the mantle up to the surface, and that's where we get volcanoes. So knowing that, And knowing that subduction zones occur along plate boundaries, go ahead and pause and make your selection for this question. So we should have chosen C, edges of tectonic plates, because where we have those plate boundaries and where they're coming together, and sometimes apart as well. We can have volcanic activity at divergent boundaries as well, because the magma will come up, and that's when we get those mid-ocean ridges and rift valleys as well. So in general terms, we're going to say that we get our volcanoes along the edges of tectonic plates, because whether they're moving apart or coming together, we're having magma erupting to the surface, and we're getting those volcanoes where those plates are. Okay, so let's submit and see how we did. And we got a 5 out of 5. Okay, so again, you'll see a few more questions from Unit 2 on your midterm, but this is a really great place for a review and to get started. So if you have any questions, let me know, and if not, you can move on to the next one.